Hey everybody, Dan here. As you can see, I finally got a camera, so now you can put a face to the name. So in this video, I thought I would address one of the polls that I put out to the community. So I asked you guys what type of Three.js tutorials you'd like to see, and the majority of you wanted to see tutorials about interacting with the scene, how to select objects, how to do raycasting. So we're going to cover that in this tutorial. So I put together a kind of a basic application that will put some of these principles to use. So I have that up on the screen right now. Let's check it out. So we have a wall of cubes here. And what I can do is I can pick any color on the side and I can paint these cubes with that color. So I can go ahead and make a little smiley face here. You can kind of move around and, it's not much more than that, but the principles that you use to build an application like this, you can use that to do something much more complicated. So if you had an e-commerce website, say you had a product that the user could rotate around, maybe there's different parts of the product that you want to be able to click on and maybe highlight that or display additional information when that part of that object is clicked. So the things you're going to learn in this video, you can apply to those situations. So we're going to start with something very basic. We're just going to do one single cube. We're going to work our way up to this 3D paint application. So let's go and take a look at the code and get started. So I've started by putting together a bare bones Three.js project. This is basically the example they have out on the website, but I'll just quickly run through what I have here just so you can know what the starting point is. So my file structure, I have my index.html file, and then in my public folder, I have my CSS and JavaScript. I'm just going to go ahead and hide that sidebar so you have some more room here. So in our HTML file, the first thing that we do is we import the Three.js packages. So notice that I'm importing the main Three.js package. In addition to that, I'm also importing the add-ons, and that's because that the camera that I'm using is called an orbital camera. So that's a built-in Three.js component, and that's in this add-ons package. We're adding in our CSS here, and then here we're importing our script, our JavaScript, as a module. So here's the CSS. It's pretty simple. I'm not going to walk through how the CSS is done in this video. It's a bit out of scope, but I am going to link the repository, the GitHub repository for all this code in the description. So you can go ahead and check out all this code later and kind of play around with it, tweak it to however you want it. So let's take a look at the JavaScript code and see how that's set up. Obviously, I have my imports at the top here, importing the Three.js library, as well as the orbit controls that I was talking about. So I'll show you how that works in a moment. So we just set up our renderer here and attaching it to our DOM. I'm setting a kind of a dark gray background color here. Then we're going ahead and creating the scene and adding some lighting to that scene. So I have a single directional light that is facing the wall and also an ambient light just to kind of fill in some of those darker spots with some light. Then we go ahead and set up the camera. So I have a perspective camera here with a 75-degree field of view. And I'm also setting up the orbital controls. So after we assign a position to our camera, we go ahead and call controls.update. So anytime we make any changes to our camera, we need to call controls.update for the orbit controls. Next, we're setting up our render loop. So this is called every frame. All it's doing is just rendering the scene from the perspective of our camera. And finally, we're setting up the objects in our scene. So to start with, I just have a single cube that we're going to render. I'm giving this just a basic gray material. And then we're creating a mesh from that geometry and material, and we're adding that to our scene. And then finally, we need to call animate. So that's going to start the render loop and get our simulation running. So I also wanted to point out that I'm using a VS Code extension called Live Server to run the application. So typically you can't just double click on the index.html file and run a Three.js app. The security settings in browsers don't really allow that. So This live server extension is super handy for that. So all I have to do is go into my file explorer here, right click on our index.html file and click open with live server. And that's going to open a new browser window and our application will be running right there. All right, so let's go ahead and check out what this base scene looks like. It's going to go over to our browser here. So with the orbit controls, I have these controls automatically built in where I can rotate around. I can zoom in. You can even pan around if you want to. So it's a really handy thing to get up and running quickly. So I highly recommend it. So we just have our basic cube here. There's really no interaction. I click on it, doesn't do anything. It's not very exciting. So let's change that. Let's add in some logic so when I click on this cube, I can change the color of it. So I'm going to add some new code after we create our scene objects here. So the first thing that we need to do is to create a Raycaster. So I'm going to define a new variable, and this will be a 3 Raycaster. And then I also need to add an event handler. So when the user clicks on the page, it will trigger some function. And then we can do the raycasting within that function. So I'm going to add a new event listener. I'm going to listen to the mouse down event. And then we're going to create a function called on mouse down. Down here. Create on mouse down. So this event handler has a single argument. So just to help out with the auto completion, I'm going to add some JS doc here and give this a type of mouse event. So how this raycasting works is that our raycaster, we need to define where it is within the scene in our 3D scene and need to give it a direction. So we're going to move it to some location. We're going to give it a direction to fire the ray from. And whenever that ray intersects with an object or objects in the scene, it's going to return those intersections. And then we can take those intersections, get those objects, and just do whatever we want with them. So first we need to set up our Raycaster and tell it where it needs to be and where it needs to shoot. So there's actually a handy method on the Raycaster called setFromCamera. So this takes 2 arguments. It's the normalized device coordinates, which we'll calculate in a second. But that's basically the 2D coordinates of the mouse, and the X and Y components are between -1 and 1. So the left side of the screen would be X of -1, the right side would be 1, and so forth for the top and bottom. So we'll create a variable in a minute called chords. But for now, pass in the second variable, which is the camera. So it's going to use the camera's position and where the camera is facing to kind of help compute that ray. So now we need to go ahead and compute this chords. So let's create a new object. And we can calculate this by taking the X location the user clicked on, and then we're going to get the render window, get the width of that. Then we're going to divide that into the X position. So that'll be between 0 and 1. So we need to multiply that by 2. That'll range from 0 to 2, and then subtract 1 to get it between -1 and 1. So let's do the same thing for the Y coordinate. Now the Y coordinate is in the opposite direction of the Three.js Y coordinate, so we need to do a minus sign here. So we'll do the client Y divided by the client height times 2, then plus 1 because of the negation. So this is our normalized device coordinates. We then pass that into setFromCamera here. So next we're going to do the fun part. We're going to calculate the intersections between our Raycaster and our scene. So I'll create a new variable called intersections. And then on our Raycaster, I'm going to call the intersect objects method. Now this method has 2 arguments. The first is all the objects you want to check the ray against. So this is just going to be all of the children of our scene. And then the next argument is whether you want it to be recursive. So if our scene has multiple levels in it, multiple levels of hierarchy, do we want the ray to cast against those deeper children in the hierarchy? So our scene is just going to be flat, so we can just set this to false. Or actually just leave out the argument entirely. So after we compute our intersections, we need to see if any intersections were found. So we'll see if the array length is greater than 0. And then we can get our selected object by getting the first intersection and then getting the object property. So this is the intersected object. And then finally, I'm going to change the color of that object's material. So we'll do new 3.color, and then we'll just make that red. This is the hexadecimal value for the color red. And then finally, for debugging purposes, let's add a console log statement. We'll just say object selected. Let's go ahead and save that. So we've set up our Raycaster. We added an event handler, event listener for the mouse down event. And then we compute our normalized device coordinates based on where the user clicked on the screen. And then we compute our intersections and find the first object that we intersected. So let's go ahead and look at the browser and see if our code is working. So if I click on this cube, we expect it to turn red, and sure enough, it does. And if I go ahead and open up the console, we can see that it also logged an object selected message right here. So our code is working just as we expected to, which is great. So let's take this one step further. Let's add some more objects to our scene and interact with those objects independently. So let's go back up to where we defined the objects in our scene. So I'm going to create a new function here called createWall. And we'll pass in the width and height of that wall. So I've created this double for loop that loops over the width and the height. It's basically going through each block in the width and each block in the height to build out that 2D wall of blocks. So within here, I'm going to instantiate a new cube at each location. So I'm reusing our box geometry because all these cubes are going to be the same. So no sense in creating additional geometry we don't need. But note that I am creating a new material for each cube. And this is very important. If we reuse the same material for each cube, if I change the color of one, it's going to change the color of all of them. And that's not what we want. So we need independent materials for each object in our scene so we can interact with those independently. So finally, I need to set the position of our cube. And I'm going to multiply these x and y coordinates by 1.05 just to give a little gap between each cube. Additionally, I'm going to set the user data for each of our cubes. So the user data, it's basically an object that we can store anything we want to inside of it. So I'm going to store the coordinates of the cube. And that way, when we click on it, we can print those coordinates to the console. So in your application, you could probably think of different metadata you can put inside of here. So maybe when you click on that particular object, you want it to display some information on the screen. So you could put that information in here. So let's go down here. Let's update our console log statement. We'll say cube at, and we first need to get the coordinates from our object. The chords equal to selected object.user data. And then let's say cube at x, chords.x, y, chords.y was selected. Okay, and then down here, we need to make sure we create our wall. So I'll just do an 8x8 wall for now. All right, so to recap, I've created a new function that creates a 2D array of blocks. We're setting a different material for each of those blocks. And we're also storing the coordinates of that cube in the user data. So when we click on that cube, we're going to display its coordinates in the console. So let's go ahead and get to the browser here. And we can already see that our wall of blocks is here. So I should be able to click on these. Let's first bring up the console. So I should be able to click on these and highlight them independently, and that's exactly what it does. And you can see that the coordinates are being printed out to the console as expected. So let's just take this one step further. Let's try and recreate what I showed in the earlier demo. Let's get a color palette on the side, and let's add the option to assign different colors to these cubes. All right, so I went ahead and added a bunch of different buttons to our document. So this is going to be the different buttons for the color palette. So you can see for each color, I have gray, white, red, orange, etc. And I've given these each a class of color button that just sets the style. And I've also have a selected class here, so that'll put an outline around the selected button. So we're setting the background color of each button. And when the button is clicked, we're calling this set color function. So we need to go ahead and define the set color function before we can do anything. Let's just go back into our main.js file, and right below our mouse event handler, let's attach a function to the window so that our HTML document can see it. Now, before we go ahead and define the contents of this function, we need to add a few variables first. So we need to add our active color. So we're going to default that to gray. Then we're also going to set up a object that contains all of our color names and the corresponding hexadecimal values of those colors. So I'm going to go ahead and add that right now. Okay, so I filled out our color library. So you can see we have the hexadecimal value and the corresponding name for each of our colors. So when we set the color, we're going to set the active color equal to the ID of our button that triggered this method. So we're going to get the click event, we're going to get the target on that click event, and then we're going to get the ID of the button. So you can see that my buttons, the ID is gray, white, red, etc. So that matches with the names of these colors here. So to add just a little visual flair, we want to put an outline around the selected button. So we'll start by getting the currently active button. That's going to be, we can get the element by ID and use the active color to get that button's ID. And then we need to remove selected from its class list. Then similarly, below here, after we set the active color to the new value, we want to add the selected class to that new button. Now, finally, we need to go back up to our intersection code here, and we need to set the active color instead of this red color here. So we'll set the active color here, and then we'll change our console log statement to the cube at these X and Y coordinates was changed to, and then we'll print out the active color. All right, so now I should be able to go back to my browser. You can see our color palette here on the left. So I can select these different colors, and it looks like I misnamed a variable here. Let's go back and change this to event here. So I have some code for reference on the side here, so I mixed the variable names up a bit. All right, so let's go back, and we can select our different colors. So if I select red, I should be able to paint this, and you can see that it's printing out the color as expected. Change to green, and let's do blue. All right, so didn't take much effort at all, and now we have a pretty cool little 3D painting app. So you can imagine you can put some more complex models in here. You could do a house and have the different parts of the house and paint those different parts different colors. Really, whatever your imagination can think of. So I hope this video was helpful for you and helped you figure out how to interact with objects in your Three.js game or application. If you're enjoying this type of content, please let me know in the comments below. If there's other videos that you'd like to see on this channel, please also leave those in the comments below. And be sure to hit those like and subscribe buttons. It really helps me out and lets me know that you guys are enjoying this content. So until next time, keep on chilling, coding, and creating, everyone. See you later.